Hi everyone, I'm Nehasree Tadikonda from BSc Honors Data Science and Artificial Intelligence program at IIT Guwahati. This is my second term project, a spam versus ham email classifier. Spam is the main delivery vector for phishing and financial scams. It wastes time sorting manually and at the scale of billions of messages every day. Manual filtering just doesn't work. So the goal here was a classifier that's fast, transparent, and accurate using TF-IDF and logistic regression rather than heavy pre-trained model. There are five objectives. Explore the dataset, compare baseline models, tune and evaluate the best one rigorously, diagnose and fix any real-world generalization gaps, and package it into something useful, just not a metric in a notebook. Coming to the dataset, we have 5,171 labeled emails from the Enron spam ham dataset, in which we have 71% of spam ham and 29% of spam. That imbalance is why I used stratified splits and class balanced weighting later on instead of trusting raw accuracy. Here's the same class distribution straight from the notebook. For cleaning, I removed the subject tag, removed the non-alphabetic characters, collapsed white space, and lowercased everything. A simple clean text function I reused in every notebook after this. And this chart shows the top words per class. Spam is dominated by promotional and financial terms, ham by everyday business vocabulary. That's useful context for something I'll come back to later. This ham vocabulary is very specific to this one dataset. Coming to the methodology pipeline, the full pipeline is first we clean the text, extract word plus character TF-IDF features, compare models, tune the best one, fix a short text gap I found, then save and deploy. This is the same cleaning as before applied here to build the training pipeline. Here I compared four classic classifiers on TF-IDF features alone, naive Bayes, logistic regression, linear SVM, and random forest. Logistic regression came out on top on F1 score, and importantly, it is the only one that gives well-calibrated probabilities, which I need for confidence score later on. This is the centerpiece of the project. Before finalizing anything, I stress tested the tune model on short, generic sentences. Things like thank you for the help with the presentation or the class will start at 10 a.m. These are obviously harm to a human. The model got only 2 out of 6 right, predicting spam for most of them. Here's why. The datasets ham emails all come from one company's internal mail and run full of specific business jargon. Short and generic sentences without jargon just didn't look like ham to the model, so it defaulted to spam. A single accuracy number 98.6% completely hit this. The fix has four parts and I add about 190 diverse templated short ham and spam examples. Add character engram features so the model can recognize spam style, punctuation, dollar signs, urgency, not just the topic vocabulary. Split the new examples into their own train and test partition so nothing so there is no leakage between the train and test. And re-verify on a held out set the model never saw during the training. Here's the template generator, sentence templates with randomized fill-in values, so I get diverse phrasing without hand typing every example. And here's the leak-free split. The email data and the short text data are split independently, then combined, so no near duplicate sentences ends up in both train and test. And this is the feature union combining word plus character engrams and the final model, class balanced logistic regression wrapped in calibrated classifier CV. So a 90% confidence prediction is actually right about 90% of the time. And here's the same six sentences again. Now 6 out of 6 are correct with high confidence. That is the fix working. Putting numbers to it, on the email test set, accuracy went from 98.6% to 99.2%, precision from 97% to 99.1%, and on short text held out, never trained on, 100% accurate across the board. Same numbers, straight from the notebook, broken down by source so I could confirm the short text fix didn't come at the cost of email performance, it actually improved slightly. This is the confusion matrix. We have 574 true hams, 235 true spams, and only 2 false positives and 4 false negatives on the combined test set. Beyond the test split, I wrote 34 brand new examples myself, 14 long form emails, and 20 short everyday messages. None of them anywhere near training. 100% correct on both, and every prediction comes with the calibrated confidence you see here. Since this project needs to be usable, not just accurate, I built a small interactive tool. I can I can type any message here, like we can type any message here and run the cell. It gives me a verdict, a confidence bar, and any trigger words it spotted. No code reading required. Coming to the discussions, for what work, the stress testing on out of distribution text surfaced on a blind spot that accuracy alone hid, and the fix generalized rather than just memorizing templates. I proved that with just the disjoint held out split. For the limitations, this is English only. It may not catch heavily obfuscated scam like this free price example. And my short text documentation is templated rather than sourced from large SMS real corpus. Overall, 99.2% precision and 99.3% accuracy on held out email data, 100% on held out short text and real world batteries, and a real diagnosed and fixed generalization gap along the way, which I think is the most valuable part of this project. For future work, a real SMS or chat dataset for even better short message coverage, comparing against contextual embeddings like a distilled transformer, adding explainability so the tool shows why it flagged something and packaging this behind a web service or browser extension. Thank you for watching. My code, notebooks, and video are linked here. Thank you.